So thanks for having me. Just by just a very additional little more introduction, I've been with IBM 28 years now. All of that time here in Poughkeepsie, and all of that time in and around System Z. And as Angelo said, I've been really fortunate to have been involved in one way or another on many of what I would consider kind of the major transformational ideas around System Z over at least my 28 years of its history. The system keeps changing. The system keeps reinventing itself. And even though it has a very long history, and some people look at that and say, well, it's old, therefore it must be archaic. If you really look at the technology in this box and in the software that runs on it, it really is in many ways state-of-the-art. It doesn't necessarily present itself very well in terms of, it doesn't necessarily always have the prettiest user interface or the best aesthetics in terms of its navigation and its consoles, etc. But if you go under the hood, it's an extraordinary system. And it's part of the reason it enjoys such a long history. So one of the things I'm here to show you is just very briefly introduce the zEnterprise system and show you what is fundamentally different about this thing versus the traditional kind of incremental generations of machines we've been producing in the past. And then I know we've got additional sessions set up to do more detail and dive into the more specific nature of how you might exploit this machine, et cetera. So what I'm going to do is stay reasonably high level as an introduction. Please, as I go through this, I'll take questions, I'll take challenges. Don't throw any food at me, that's all I ask. But I always enjoy the interaction. I'm actually better when that happens. I get more out of it, and I always get something out of it. So with that, let me get to it. As a context, I was asked, along with a few others, about 4 years ago, to start thinking about how we could extend the System Z platform in the mainframe to extend its value proposition for our customers and to be bold. I was kind of asked to think outside of the box a little bit and be aggressive, right? So I got a few of my friends together, and we started looking at things. We looked at trends in how systems are used, how software is being built. We looked at service orientation and how in the world of software, people are taking big monolithic applications and busting them apart into smaller, finer-grained components and reassembling them and composing these things in more flexible and dynamic ways. We looked at the trend towards specific machine architectures and how they were either better or not so good, or better or worse suited for a particular type of workload. IBM has many computer system architectures. Its System Z architecture and its microprocessor and its memory packaging, etc. The way the machine behaves tends to be designed for a certain type of workload and optimized to that workload. Our IBM Power systems have a slightly different design point, and they're really optimized and targeted to some things that System Z doesn't do so well, but likewise, Power doesn't do all of the things that System Z does very well. And then, of course, you've got the x86 stuff that is also, people argue about how general purpose that stuff is. But we have all of this variety, and we have all of this diversity. And it's not because all of these systems are just duplicating all of the features they all have. They really are distinct, and they can be used for very different purposes. So we looked at the trends with that. We looked at the trends to extend hardware with very fit-for-purpose specialized compute capability. We looked at special-purpose hardware accelerators. We looked at different forms of appliances and coprocessors. And the third thing we looked at was virtualization. And everybody's chasing virtualization, and everybody's kind of virtualization happy these days. IBM likes to pat themselves on the back, System Z in particular, for actually having invented the notion of virtualization in various levels of the system. In the hardware, I think we can still brag that we have the best integrated and most efficient, highest performing virtual hardware in the industry. I won't go into all the details of why I still think that's true. But it's not just about how efficient your hardware is anymore. It's about whether or not the notions of virtualization and advanced virtualization can be used in a way that extends the value of the platform, and whether or not virtualization can actually help in managing the complexity of the infrastructure. So we took all of that, right, and we kind of built a proposal, and that's what zEnterprise came to be. So from 3.5 or 4 years ago to now, we now have a product. It's a major part of the System Z strategy here in Poughkeepsie. What I'll also tell you is there are components or conceptual notions in this that are now being adopted in the other IBM platforms as well, outside of a System Z context. So, that is by way of a little bit of a history on this. Let me explain this chart. I committed heresy when I brought this thing forward to the IBM company, and especially from the standpoint of the Z guys. Because the first thing we said is, not all business workloads, not all compute workloads run on a Z engine. Right? And the Z guys, of course, say, well, yes they do, or yes they should, or yes we will make that true. But we pointed out that, you know, across IBM we have the diversity of these different computer architectures, and they actually should be used in a way that together, right? You celebrate that diversity, you use the right part for the right job, and together, if you were to integrate these things together, more so than we have in the past, we would actually have a virtual heterogeneous system that was capable of much more than just each of the individual systems themselves. The other thing we recognized was that customer workloads, whether it be the traditional Z workloads in banking or insurance, or supply chain management, or manufacturing, or any of the others, even now getting into healthcare and life sciences, or engineering and aerospace. All of these workloads, my assertion is, are inherently multiple tier and heterogeneous in nature, right? With the advent of distributed computing, you deploy software components on different architectures, and you integrate these things together with distributed interactions across the platforms. And that's the way people are building stuff. Especially with the re-engineering that's going on in software, is to take these monolithic, inflexible applications, ripping them apart, understanding what are the reusable components, and then reintegrating them in flexible ways. You have all this business process integration that's going on, and it inherently, right, you have some parts of the business application that run best on a Z engine with a ZOS environment, and you may have some of that application, that distributed application, that runs best, say, on a Unix or AIX or Linux environment, for example, on some platform. You may have another part of it that really is best suited, not only in terms of the need in terms of its compute capability, but cost. It's a better cost equation to run this stuff on maybe a platform that doesn't demand the premiums, because you don't need some of the stuff that the higher end stuff needs, right? So that whole notion was very basic to what we did with zEnterprise. We said infrastructure looks like this. It's really messy, people have a lot of stuff on the floor, it's heterogeneous in nature, and what we need to do is provide a better mechanisms to be able to integrate this stuff together, provide single points of control for its operation, single points of capability for monitoring it, for recovering it, for performance optimizing it, for securing it, right? Rather than having each one of these things in an IT shop be separately managed by separate people with different skills, with different tools, right? When you do that, you have higher cost, you have higher complexity, You have systems that are fragile because you don't understand the relationships between them in terms of how they're surfacing the workloads. So if you change something over here, you didn't have the insight of the relationship this thing had with something else, and it causes some unintended effect over there, which leads people to not do that, right? It constrains their ability to be flexible and dynamic in configuring and repurposing and deploying applications on these systems, because change, right, is often disruptive, right? So the idea here is to take this environment and not worry so much about my product, my mainframe, or my mid-range power system, or my x86 thing, or my DB2 implementation, or whatever it is, and really focus on what does the customer need, right? What does the customer workload look like, and what are the pain points customers have in managing and reducing the complexity and cost and increasing the resiliency of managing this environment, right? And that's what we focused on with zEnterprise. So here's what we announced and started to deliver. I like to talk about zEnterprise in with three different components. On the left-hand side, we have the zEnterprise 196. This is the name for our high-end mainframe engine that we announced last July, not this previous July, but the July in 2010. And you can think of that machine as, from a hardware perspective, as the next turn of the crank, the next generation of Z mainframe, right? If we had not done anything else in zEnterprise, we would have been very proud and happy to deliver that box. Just to give you a little bit of background on this, if you like these things, it is a monster. The Z196 stands for, the naming is kind of interesting. Z1, that's the first generation of zEnterprise. It's a new generation family. 96 is, in the first generation, the number of processor cores, right, that can be configured into the machine. 80 of those cores are available for customer use in one way or another, right? We've improved the performance of this box anywhere from 40 to 60% when you measure it by our traditional transaction processing workloads, generation to generation. The previous generation of Z machine was referred to as the Z10, right? You can put up to 3 terabytes of memory on this machine. That is up from 1.5 terabytes of memory in the previous machine. We've introduced redundant array memory, so we took the concepts of RAID, as it's known in disk systems, and implement that in the memory system, so we have additional sparing and resiliency in the memory. We did a lot of work to introduce what we refer to as out-of-order instruction execution in this machine. So we parallelized the pipeline of the machine so it can execute a lot more of the basic elements of the processor in parallel, and we got unintended, actually surprised us, improvements in the floating point performance of the box. So if workloads that are floating point or more compute intensive that run on this box, they saw an even bigger jump in performance than the past generations of machines. So that's about all I'll say about it. There's a lot of very unique engineering in this thing. I will tell you that if you were, if I were talking to customers about the strategy of the machine, I usually talk about what might be next here, and what's next, I'll just say without going into detail, is that the pursuit of compute-intensive performance is a very specific and primary kind of priority now, right? More business analytics, more real-time analytics, not just data analytics, but compute-intensive analytics, the ability to take large amounts of data and do not only just reporting, but predictive and prescriptive analytics across this, not only demands high capacity and good performance in data management and data processing, but is going to require compute-intense performance above and beyond what we have today. So you're going to see the next generation of Z machine focus on a lot of cores, a lot of memory, hardware multi-threading, vector units, for vector arithmetic, both integer and floating point arithmetic, and that is in our future. Okay? On the right-hand side, we introduced an optional capability, and we called it the zEnterprise Blade Center extension. And I don't know how familiar you are with the different form factors for the hardware, but this is an infrastructure that is the host of very modular compute elements we call IBM blades. And you can use this infrastructure to literally plug in these compute blades, either IBM Power System blades or x86 blades into this infrastructure. And the idea was that we supply this as a logical part of the Z system so that together these things logically are integrated, incorporated, and managed together as if they were one system. Right? So what you see as kind of the management persona for this box is, even though these are separate physical entities, what we present, right, in terms of how you deal with the system, how you configure it, how you operate it, how you turn things on, turn things off, how you service it, how you performance manage it, from a hardware perspective, is all logically integrated as if it's one system. This is the part that's somewhat unprecedented in the industry, right? Because all of the machines, no matter whether they're small, low-end or high-end machines, have always been defined by what instruction set architecture they run, right? And everything was vertically kind of integrated to suggest that that's the identity of the machine, right? Which forced this distinction on how these boxes were managed out to our customers. Right? You have to manage a Z box different than you manage a Power box, different than you manage an x86 box. What this said was, what we're going to do is we're going to focus on a management system across this thing so that we logically integrate these things and present a virtual single system image that is built out of different components that never were put together before. Right? And in doing so, the idea was reduce costs, better result in terms of reduced complexity, more resiliency, et cetera. And I know some of the sessions that we have coming up, at least one of them is going to dive a little bit deeper onto some of that. The third part is the management stuff that I talked about, and in some ways that's the most important part of the zEnterprise hybrid system. Because what we've done is we've taken a bunch of management tooling and we've burned it into the machine, right? We've actually taken what would otherwise be add-on management software that a customer would have to go out and acquire on his own, install, configure, service, patch, tune, optimize. And we brought those capabilities into the machine, delivered it as a native part of the firmware of the machine. And so it's like the old Prego or Ragu, I can't remember which sauce it was, it's just in there, right? You turn the box on, there's a bunch of firmware that gets loaded and deployed, and there's a set of management capabilities that just come up pre-configured, pre-integrated, ready to go, right? Enormous value in terms of reduction of complexity in having customers put these parts together themselves, having to know what parts are compatible with which, what are incompatible, the versions, whether this stuff works together. All of the service, all of the maintenance, all of that stuff is just taken care of as a part of the base firmware load of the machine. Okay? So integration is really the key value. So this unified resource manager is a set of management capabilities that is inherent in the machine. So let me, without diving into technology, let me kind of set another context here. If you look at the way systems are built and the way we use these systems, you have layers of stuff, right? At the bottom, what I depict here is you have physical things. You have physical servers, physical networks, physical storage devices, different types of hardware accelerators, appliances, et cetera, that are even more of these things as we speak. And what has been happening now and is accelerating is that you take each of these IT components and you put some kind of virtualization capability on them, right? You virtualize them. So you take a physical server and you put hypervisors and virtualization stuff on it so that that physical server to the software actually looks like multiples, right? We did this with virtual storage. You can virtualize anything. I actually happen to believe that we might actually be living in the Matrix. That movie was superb, and I believe it's possible. So then you carve up the machine, and what gets presented to the software is virtual containers, virtual servers, virtual disks, virtual networks, which are all projections, right, of what looks to be a real thing onto a physical thing that's shared, right? So you can get multiple virtual servers now that are actually sharing, and basically time sharing in some ways, the physical resources of the box, okay? That's all kind of well-known technology, and everybody's chasing that. You have that across Z things, Power things, X things, HP things, Dell things, whatever. Pick your flavor, pick your vendor, right? Everybody's kind of doing this. On top of that, you fill up these containers with software, right? And typically, the first thing you put down in these guests, we refer to these virtual servers. The code, the application, the software that runs in these are referred to as a virtual guest on the machine. You fill them up with operating systems. So Ange will tell you, you put ZOS on these things, right? You put ZOS in System Z LPARs, right? You put Linux images on virtual machines that are managed by a ZVM environment on Z. You put AIX or variants of Unix and Linux on Power, on their version of a virtual server, et cetera, et cetera. Of course, on top of operating systems, we have software and middleware and transaction servers and database servers and messaging servers and all kinds of stuff. And one might then say eventually you actually get some actual business function in here which the customer cares about in terms of applications. All right, so why did I take you through any of that? Is to give you a sense of what zEnterprise is. With this, my view is that with each of these layers in the system comes a responsibility for managing the resources associated with that layer. And this is where the industry, I think, continues to kind of be confused and somewhat chaotic, because there isn't really, you would think there was, but after all of this time, there's really no fundamentally agreed upon taxonomy or architecture for who has authority in a set of management software, who has authority for managing the various resources in the system. Everybody breaches their boundaries, right? There's one tool that wants more value by some vendor, and it's going to manage thing A and thing B. And if it's really best suited at managing this stuff, it typically tries to manage operating systems and middleware too. And then you've got 17 guys trying to manage the same piece of middleware application, and chaos ensues, and it's not integrated, it's not coordinated, and you've got taken a problem that you were trying to solve, and you've actually made it worse for the customer. Biggest complaint we have, right, with systems these days is that the very tools that are intended to make management of the system simpler actually make it more complex, because the management tools don't integrate, they don't install, they don't work together, they don't have the same perspective on the resources, they have different policy semantics for how to manage things, they get in each other's way. We've realized, that one of the things we brag about in System Z and ZOS, well over half, and Ange probably knows this statistic better than I do, well over half of the lines of code in a ZOS operating system now are recovery code. Well over half, right? What we're finding now is that there's so much recovery code, the recovery code gets broken. Right? There are elements of the system that start to take on responsibilities when they see certain things happen, right? Oh, this air condition happened, I've got to respond to that. Oh no, that's my job. They're not talking to each other. I did this, I did that, they're incompatible, right? And in some cases, you got to be really careful that, in the attempt to make things better, you've actually made it worse, right? So anyway, that's what we've got in the industry with management tooling around these systems. So my view is infrastructure has, there's an inherent responsibility for infrastructure providers, meaning servers, storage, network, physical things, virtual things, to provide with those resources the inherent capability for managing them. Same thing for operating systems and middleware. ZOS has its operational view, it has its console, it has its automation, it has stuff that you use to manage the system, and applications bring with it their own view of that as well. Okay? So, what is zEnterprise? zEnterprise, the product, is a set of these heterogeneous compute elements that are virtualized. We've introduced what I think is advanced virtualization capability across those systems. So the ability, for example, to take a live running guest and pick it up and move it to another system without disrupting it, without having to take it down, without having to even pause it. Just pick it up and move it, right? Virtualization starts to give us these kinds of capabilities to do even more dynamic things, optimize the system, and tune the system for various reasons that we didn't have before. So this is about the integration of the physical hardware, different architectures brought together, introducing advanced virtualization, and introducing the management of the physical and virtualized environment in a tool that comes with the platform. So when I talked about that unified resource manager before, that's what that blue box is, that blue oval, okay? The zEnterprise product provides hardware, virtualization capability, and the management of that environment across Z, Power, and X, right? In order to support these heterogeneous workloads that can be deployed on it. So now you have your choice. If you have an application that really runs best on an Intel processor, and I know there are those cases. If you have a scientific application that would be best run on a power system because it excels in superscalar operation, or it has the kinds of compute intensive capability you need. Right, for example, Jeopardy, right? You saw the Watson thing, right? That was built out of power, IBM System power components, right? For a reason, right? Because it is the absolute best system currently across our portfolio for doing the kind of work and the kind of computation that was required to pull that Jeopardy thing off, right? So the point here is that you give people the choice in being able to develop their applications and host the various parts of their applications on the right part of the system, and then still give the customer a single point of control, a single set of monitoring, a single approach for doing updates and service and optimization and monitoring and automation, et cetera, across the infrastructure, right? And you get the best of both worlds. That's the idea with zEnterprise. Now, for those of you who are tracking all of this stuff about cloud computing, in some ways, cloud computing is another name for stuff we've been pursuing for a long time: utility computing, service-oriented kind of approaches to delivering IT. If you get below the marketing hype, there's emerging a taxonomy and an architecture here that is going to help us. It's going to formalize how people use these systems and how they're built. And I won't go into detail here, but it just so happens that there's these notions now you'll hear of infrastructure as a service, or platform as a service, or software or business process as a service. It's our view that what we've done with zEnterprise and the capabilities we've introduced into zEnterprise, the ability for us to dynamically configure the system, to dynamically provision new virtual resources on the system. You want a virtual server? Bring one up, right, across any of the Power, X, or Z platforms. The ability to instrument this and account for its usage, so that if I've got multiple users that represent different tenants, right, in a service, in a utility-based model, I can actually account for and charge for the capacity that's being used on the machine because I've instrumented this thing in a way and enabled it for that kind of purpose. So my view is that, and we're not the only guys in the industry doing this, but my view is what we built with the zEnterprise platform is tailor-made as a foundational infrastructure for cloud, right, at the infrastructure level. And that's all I'll say about it. And it just happens to map over a number of things IBM is doing to extend, the stack across each of these management tools to pull this thing together, to federate the layers, and to offer a consistent way of managing the system in a cloud environment. Okay, so what is it? On the left-hand side, you've got a Z system. And the way this thing is built is, for those of you who are familiar, is you've got traditional Z engines. You've got Z cores, Z CPUs, and in all of their flavors, right? We've got special engines that are dedicated for hosting Linux workloads. We've got engines that are designated as being dedicated for ZOS workloads. If you know anything about coupling, Angelo can tell you all about Sysplex. We work together on this. We have engines in the system that are dedicated to an appliance we call the coupling facility, which is a dedicated virtual device that handles locking and data sharing kinds of capabilities. So all of that is in there. And then we have our hypervisors. So we have in our system layers that virtualize the hardware. And so we have this thing called Prism and ZVM, which is the System Z virtual machine hypervisor. And on top of that, customers deploy virtual guests. So they deploy production level ZOS images on these first level LPARs. And traditionally, we've got a lot of Linux running on the platform now. Linux is typically hosted in a second level hypervisor. We have 2 levels of virtualization here, which nobody else really has. But that's the system. And that's kind of traditional. Then this over here is the ZBX part of it. And in the ZBX, you can plug in either x86 or power blades or special purpose blades that have a very specific purpose for accelerating relational database or accelerating compute-intensive applications, or DP stands for data power. IBM had acquired an appliance called Data Power, which accelerates and processes web service and does XML acceleration and web services security, message transformation and adaptation. So there's emerging these specialized components that do a very specific thing but do it very well, right? So the idea is that when these are hosted on these x86 and Power Blade form factors, you can plug them into an infrastructure and you can manage them logically as though they were a logical extension to the system.
Let me ask you something. I'm sorry if I'm interrupting.
No, please.
What's the connection between, for example, the Linux on the C part of things and the Linux on the, let's say, how would you call that, the Blade extension side of things? Or put it this way, what's the connection between a Windows Blade extension with a Linux server on that side? Is a Windows or Linux virtualized on the Blade extension?
Yes.
Being controlled in a certain way?
Yes.
You mentioned
Yes, yes, I'll get to that in a minute. All of this hardware and all of these hypervisors, right, the yellow things, we actually, in the Unified Resource Manager, provide a federation of the management across every one of them, right? And I'll show you why that's kind of important in just a minute.
Okay.
If I take you specifically at your question, you asked how they're connected. Maybe you meant that, I don't know, but what I think you may have meant is how they're related or how they're managed, and I can discuss any part of that if you'd like me to.
I don't want to disrupt your.
Okay, well I'll get.
Yeah, please go ahead.
I'll get to it anyway. I'll get to it anyway. So without going into a lot of detail, the point is that these are general purpose engines that run whatever Power, X, Windows, Linux, AIX workloads you want to run, right? The fact that we manage the underlying infrastructure doesn't intrude upon the choice you make as to what to put on those, right? So these are standard, right? Any AIX, any Linux, any Windows application workloads you want to put on these blades, you can put on them, right? The idea with zEnterprise is to integrate and make more efficient the underlying infrastructure and to optimize the resources that are being allocated to these workloads better than they would be if they were standalone systems. But unlike, for example, Sysplex, where a fundamental change in our underlying architecture rippled through the entire software stack, that's not the case here. The fact that these software images are running on a zEnterprise system, either on an X blade or a Power blade or a Z blade, is completely transparent, right, to the application that they're running in this configuration. Okay, my view is that the value proposition of zEnterprise is that when you take one of these AIX images and you move it from a standalone system onto this, it's better utilized, it's going to be recovered better, it's going to be optimized better. You're going to get better overall utilization of the entire environment because we understand, we have an end-to-end insight as to all of these workloads, what they're consuming, how they're using the resources, etc. Okay? So it really is largely focused on allowing people to do what they always do with these systems for Power and X and Z, right? To offer that freedom while also then suggesting that if you put that stuff on an integrated platform and manage it as a single logical thing, there's efficiencies and optimizations and cost you can get out of it. Okay? Yeah.
Question. The SE on the bottom of the
yeah.
left stack and the ANM on the
yeah.
bottom. What are those?
Yeah, yeah. I wasn't sure whether I should dig into that, but at a high level, SE stands for support element. It actually is a couple pieces of hardware inside the Z system that are responsible for controlling the hardware. So when you turn the machine on, right, it's the SE that's actually talking to all of the service processors and all the micros and all the stuff inside the box to orchestrate the operational controls of the system. The SE also is the primary place where hardware is monitored to determine if it's failing. So if I had an engine in here or a channel or a network card or something or a piece of firmware that fails, the SE will know about that, will talk through the hardware management console and actually contact IBM. We'll call home, right, report the problem, right, and we will then dispatch service guys to the location, right, and those guys will rip open the covers here, a lot of time with the replacement part in their hand because it's been reported, and then use the support element to do field-guided repair and verify the box right on site. So it is a very important and largely overlooked part of the system. It doesn't make the glossies, right? But it's the underlying operational control for the platform, right? So what we've done, to your point, to your question, is we've taken the capabilities in that. For example, you know that you probably know that in System Z we can dynamically allocate additional capacity on demand. Right? These are the things that are controlled by the support element. All of the firmware that's loaded on the box, the levels to apply firmware change and to back it off, to make sure it's compatible, all of that is held within the SE. Okay? We've taken all of that function that was provided for System Z, and now we just applied it to the blades. Right? So the point here is that you've got one tool, one integration, one process for all of this stuff, right, across this entire environment, right? And this is the thing that surprises people, because if people, people are used to how they're managing standalone x86 blades, right? We tell them, you don't have to do any of that anymore, right? We talk to customers who are deploying their own hypervisors, whether it be VMware or KVM or whatever, and if I've got a customer that's got 6,000 blades right on the floor. That's 6,000 instances of hypervisors. They have to manage all the licenses. They have to manage all of it. They have to go get them. They have to manage their installation, their configuration, their support, their service, their tuning, everything. And with this, we treat those hypervisors as part of the system firmware. So we just say, you buy the box and it's in there. Turn it on and it goes, right? I mean, there's just all kinds of reduction of complexity just by removing the number of moving parts in this thing, right, that are exposed to the customer. Yeah?
So does that imply then that installation of those individual boxes is either streamlined or somewhat eliminated, but does it add complexity to the installation of the overall zEnterprise system itself? Kind of two questions there.
Yeah. Oh, well, the first one, you know, if we don't deliver on the value proposition, which is reduce complexity, right, we shouldn't have done it. So time will tell. It's relatively new. We haven't got everything done yet, but that's the intent. For example, what I don't have time to show you is that once you understand this configuration, then we allow you to cluster these, right? So you can have up to 8 of these systems all clustered together, right? So you have an aggregate capacity, you know, 8 times this, right? All managed by a single point of control. Networking, which again, I'll just kind of briefly talk about. What's inside this, what connects all of this stuff together is an integrated 10 gig layer 2 network that connects everything to everything, and it's just pre-assembled. It's in there, right? In fact, it's also, we claim, private and secure, because that internal network that connects all the Z parts to other Z parts and blades to blades and blades to Zs, right, in this configuration, runs only through networking switches and adapters that are inside this configuration. So the network doesn't run through any customer managed layer 2 switch or layer 3 route. And so we've been able to convince people it's private, secure. So things like, you know, customers look at this and they say, okay, well, now I don't need to put a firewall, right, between this thing and that thing because, right, it's all internal and private. Now I can eliminate the encryption that I would otherwise do from point A to point B, right, because there's no way that anybody can see this stuff outside of the box. That has, you know, the obvious effect, and then it has the second and third order effects of reducing complexity, reducing the amount of MIPS you're chewing up on each end of the device by doing encryption, et cetera. And it also removes a lot of the physical hops in the network that you would otherwise do. You look at SAP applications or distributed applications that have parts running on X, app servers, NQ servers running on AIX systems, talking to back-end ZOS databases. We've done some studies that show that with this simplified integrated private network, you can take a typical SAP transaction and reduce the number of physical network hops from like 12 to 2 in a given transaction. So there are efficiencies here that are brought about by the close proximity to this, the integration of this stuff. These hypervisors, by the way, since we treat them as system firmware, the other claim we make from a security standpoint is that they're part of the trusted compute base. Right? Now, we like to brag in Z that we know a little something about security and integrity of the system. So what we tell people is, you know, those hypervisors, they are digitally signed and delivered as System Z firmware. Once they get into the system, right, we treat them as firmware. So they're not accessible on any customer network, right? The only way to manage them or to change them or to configure them is through my Unified Resource Manager firmware, which is the purple stuff, by the way, on this chart. And so what's that mean, right? When people really look at this, they say, okay, well, I've virtualized the network. So I've got, these hypervisors have virtual network switches in them. Well, if you're going to deploy virtual LANs, right, on a physical LAN, you have to make sure that each of those virtual networks are isolated from the other virtual networks on the same physical fabric. If you allow any Tom, Dick, and Harry to configure the configuration of the virtual LAN ports in those virtual switches, right, you've got a breach of integrity and security. So what we say is, you can't do that with this system. The only way to do that is through my locked down system firmware management devices. So it's more secure, it has more integrity, right? Since they're firmware, I tell the customer, you can be guaranteed that there's no third-party agents in this thing. There's no third-party bugs that are introduced by somebody screwing around with it. It doesn't have any malware in it. It doesn't have any virus in it, right? It's System Z firmware, right? So these are all the kinds of, just trying to give you a context for what we built and why we built it, okay? So the network on this thing is kind of an important part of it. The other thing that we pride ourselves, and we have prided ourselves in System Z on, is being able to monitor and report and optimize the use of resources based on what we know about the service levels that are required from the applications. System Z has a reputation for being able to run lots of workloads on the box. Each of those workloads have different business levels of importance. Some workloads are more important than others. Some workloads demand a service level in terms of their performance or response time that are greater than others. Some of the workloads and some of the applications demand a greater level of resiliency and recovery and availability than others. There's all kinds of parameters, right, to managing multiple workloads on a shared infrastructure and allowing each of those workloads to have their own requirement for the service levels, and then to have the system be intelligent enough to align the management or the allocation of resources in alignment with those goals, right? This is where the magic happens, and this is where this system allows us to do that, not just in the tier that runs on the Z, or not just in the tier that runs in Power, or not just in the tier that runs in X, but it allows us to have insight as to the relationship between these images that are running on the box that is really the customer view of the business process, right? The customer view of the application is it has some web servers running out here, and some app servers running here, and some other app servers running here, and some database transaction systems running here, right? They don't want to look at this system and manage it by saying, oh, my database has a problem. Because what's really important to them is that my business function has a problem. My ATMs are down, right? And my ATMs, right, are implemented with all of those parts, not just one of them, right? So what we do in zEnterprise is we allow you to specify, we allow you to tell you that these things are related. And we allow you to say that it constitutes some workload that's important to the customer, and then we say, hang some policy on that. Tell us what the performance requirements are of this thing. Tell us what the availability requirements are for this thing, right? And how they're different, more or less important than another set of these images that are running on this box. Then what we've done is we take and we build in intelligence into these hypervisors and into this unified resource management device so that we can monitor the resources that are being consumed, we can monitor the failures, we can monitor the bandwidth, we can monitor how the resources are being used and allocated across this composition of things, which is the customer workload. And then we can report on how well things are going against the goals, and we can make optimizations. So for example, if the overall velocity or throughput, right, of a given workload is suffering, it's not meeting its goals. I said I needed to have X response time for my transactions, and I'm not making it, right? The system can now look at that and say, well, I know you're not meeting your goals, so where might be the best place to make an adjustment to optimize the resources so that we can bring that workload into compliance with its goals? And what intelligence can I apply so that I can make intelligent trade-offs between the way I'm optimizing this workload so I don't hurt some other workload of equal or more importance, right? So long story short, we have an understanding in this layer of the system across the heterogeneous hardware as to how these things are doing. And for example, and Pete will probably talk about this in another session, if we need to allocate more virtual CPU to this Linux image, because we've determined across this set the best place to make an optimization is to give this guy a little more CPU. We can understand what effect that might have across this workload and the other workloads, and this URM stuff can go over here and talk to this hypervisor and ask that hypervisor, take some virtual CPU from this Windows and this Linux image that are of less importance and temporarily give it to this guy. Right? He needs a little boost. right? And in doing that, right, this thing will improve, which makes this thing improve, right? And we can have, you know, more intelligence and more insight across what's really important to the customer. We pat ourselves on the back for this kind of thing in Z and ZOS today, right? And rightfully so. We took a lot of the notions of ZOS and we kind of pulled them down into the hardware so that they extend to more of the customer business workload, right? The problem with it in ZOS is that it's limited to ZOS, right? So we can optimize the hell out of this thing right here. And the rest of this stuff, you're on your own. Matter of fact, being a Z guy, right, we used to actually point that out. You know, if you're focused on selling this box, then what you want to tell the customers is, this thing is good and these things aren't, right? And so you should get all your work over here because I can optimize this thing better than these guys can optimize those things. Until you realize that the real value to the customer isn't to force them, right, to unnaturally host parts of their business on architectures that aren't as optimized for that part of it. You have a different perspective and you say, how can I optimize the overall configuration of the system to best meet the needs of the workload? And that's what's different about zEnterprise. That's what's different about the cultural or philosophical basis of this, right? I can tell you that the other question I get is, well, I've got customers who are organized in ways that aren't really good for this, right? I got my Z shop, and I got my power shop, and I got my distributed thing. You know, so I get questions like, who owns this thing, right? And that's where I soft shoe and I try to convince people that the constraints they have in terms of the way they're organized and the way they have instituted their IT governance is actually a constraint to them, right? And this gives them the opportunity to integrate around it, right? To really do the same thing we're trying to do, which is to provide them a way to focus on the business value and the business workload, right? And integrate around it. I'm free to admit that we could have done the best job at integrating all of this stuff together and providing a coherent and consistent management approach for this thing. And if the customers aren't willing to integrate around it, right, they're not going to get the value out of it that we think they can, right? So it varies by customer as to, you know, how amenable they are to this transformation. I'm going to start to kind of try to get to the end of this because we're kind of out of time. These animations are not really anything new, but I just, in terms of the industry perspective, but I just want to kind of draw your attention to what I mean by more dynamic provisioning and virtualization capability. So the idea here is that there are emerging standards that allow you to package entire compositions of software, operating system, middleware applications in a package that will get deployed into a virtual server as kind of a unit. If you go to, not that I'm going to point you to VMware as an advantage here, but there are, if you go to VMware, right, you can look at, you know, these sites that provide these virtual appliances, right, that are basically pre-composed, you know, compositions of software that you take them as a unit and you dump them in a virtual machine and they run, right? They're kind of pre-configured, pre-assembled, etc. We refer to those as virtual images, okay? So there are emerging standards and approaches that allow you to package these things up, put them in libraries, share them, deploy them, right, with greater dynamism and greater efficiency and lower complexity. And what you do basically is if you want to deploy a virtual machine image, you take some of the metadata from the description here, and you dynamically provision a virtual machine. Its memory, its processor, its storage, its network connections, etc. And then you take the image, the software image, you drop it onto the backing disk that is in back of those images, and then you boot or IPL that image into the machine, right? So it's a little different granularity of how people are starting to manage how they construct software, and it's because of this dynamic virtualization capability and the ability to use virtual machines as very flexible, even fine-grained containers for deploying applications, right? Because you can deploy them quickly, you can remove them quickly, right? And you can start to do things that that are kind of non-traditional, right? And of course, if you can go that direction, you can go the other direction. You can pull these things out and populate image libraries, take a snapshot of the configuration of the virtual machine, right? And package that all up in a manifest, and then you can clone these things, you can sneaker net these things around, you can use these things for various reasons, right? You can even start to put these things in catalogs and offer them as services, right, under subscription services, and have people pay for them, right? This is kind of some of the thought behind what is enabling, right, more efficient cloud and utility-based computing, right, is some of these kinds of notions. The other thing is that you can use advanced virtualization now to dynamically provision resources, a virtual machine on some node in the cluster, and while that image is running, actively running processing workload, you can move it live, pick it up and move it from one place to another, and then deallocate the virtual resources on the source. Why would you want to do that? Maybe I'd want to do that if I had a need to rebalance capacity. Maybe I'd want to do that if not everything in this machine or that hypervisor is concurrent upgrade. Maybe I have a planned outage that I want to do maintenance. I want to move virtual images around non-disruptively, introduce change, and then roll them back. Maybe what I want to do is I'm concerned about energy consumption. So I want to consolidate all my virtual machines, right, on a smaller number of physical boxes, and then put some of them in power savings mode or turn them off altogether, right, because I want to save some energy. Yes, sir?
Jeff, VMware has that ability right now.
Yes, it does.
Okay, and I'm just trying to understand what you're explaining and what VMware provides.
Yeah, it's a great question. So let me try to address it. In terms of the basic foundational elements for managing virtualization, right? You can point to some differences. Some people have more, some people have less. But I actually give VMware credit for this kind of an innovation, right? Now all of the hypervisors have this kind of capability. So what makes it different? What makes it different in the zEnterprise case is that, as I showed you in the previous chart, maybe what I want to do is use mobility as a mechanism for optimizing performance across the environment. The difference between this and something like a VMware, right, and you could argue better or worse, my assertion is that we do heterogeneous, right? VMware is their stack, their vertical stack on x86 only, and all the rest of the part of the workload, right, somebody else's problem. My second assertion is that this kind of capability is just table stakes. What the real value proposition in mobility is knowing when to do it, why to do it, where to put the target, right? What we do and what those guys do and what we do today is, because we're all kind of just getting into this, is that we provide these basic functions to say, if you push a button, I'll provision stuff over here, or if you push a button, I'll move this thing over to there. And then we give the hard problem back to the customer and say, you got to know why to do it, you got to know when to do it, you got to know whether you have capacity somewhere to do it, you got to know whether or not you have software licensing constraints that would permit you to do it and stay out of jail. You have to know what your availability configuration is, so that when you move this thing from here to here, you didn't introduce a single point of failure and actually degrade the availability of your system, right? You got to know the energy consumption. You got to know all of that stuff. So this isn't nearly enough. This is just a foundation. And so what we're pursuing, what we haven't delivered yet with zEnterprise, is this, which is intelligence on helping, right, automate the placement of these virtual machines, right? So if you want to deploy a set of virtual machines, right, you suggest a set of policy. What's important to you in terms of performance or capacity or software licensing constraints or energy consumption or security and isolation. I got Coke and Pepsi that want to run on the same box, right? And we got to guarantee that those two tenants from a security and integrity perspective are absolutely isolated. Maybe what we also want to do is make sure that since they're paying for a certain set of availability service, that if Pepsi happens to do something on the box that takes down Coke, right? We don't, a service provider can't allow that kind of thing to happen, right? So a lot of this is affected by where you put stuff, how isolated it is, how secure it is, what the capacities are, et cetera. So what we're doing is we're starting now to introduce this kind of intelligence in the box. So to your question on VMware, how public is this going to be? Am I violating business conduct guidelines here? Hey, listen, these guys, all joking aside, they are real innovators, right? My view is that ignoring the heterogeneity of customer environments is going to be, right, you're going to have solutions no matter how good your stack is, right? You're not going to be able to deliver, if you only focus on one part of the stack, you're not going to deliver the kind of value you could otherwise, right, to the customer. And second is, the idea is that the differentiation in all of these different approaches are going to be in how intelligent your infrastructure is, right? Do you do a really good job at kind of configuration, but you don't do a very good job at dynamically optimizing, right, resources to the system? Do you have an understanding of the service levels that are needed by the workload hosted on the system? Do you understand the relationships between these things across the tiers? If you make an adjustment to optimize performance, do you know whether or not you just compromised availability or security, right? Do you have the mechanisms for the customers to declare the weight or the relative importance across these parameters of the optimizations? And then do you have the mechanisms, the monitoring, the heuristics, almost the artificial intelligence in some ways to make intelligent decisions about the optimization and then deploy that optimization, right? So yeah, I agree with you. If you look at this kind of on a superficial level and people say, yeah, I've got mobility, he's got mobility, whatever, right? No, mobility is just a tool, right? I don't go to a customer and say, man, I got a slick system, you can move stuff, right? Why? Right?
We're going to need to wrap up.
All right. Good. You have these charts. These are just animations that actually depict what we've talked about. This is, the ability to move resources around or to use mobility because I want to affect performance or availability. And Peter is going to talk more about this. And so I've got examples where we've got various stages of this implemented where we can move stuff around, put stuff, in power management modes that use less power envelope. We can even vacate entire elements of the system. Well, actually, we can't quite do this yet, but we will have the ability to vacate entire elements of the system and then just turn it off, right? All in automation, right? And turn it back on and repopulate it later. I've got kind of a summary of some of the stuff I've talked about here at the end, and that's about what I wanted to do today. I wanted to wet your whistle on what zEnterprise was all about. It's not just a mainframe box that's fast and water cooled and stays up. It's about how can I start to integrate these systems in a heterogeneous way, allow you to deploy the workload on the part of the system that makes most sense rather than forcing your hand. The x86 guys will come in and say, this system can do everything. Everything should run on X, right? It's my job to make sure that that's not true. But you know, it's just as invalid to say that about Z, right? Not everything should or could run on Z either. So this is about, you know, integration, right? Optimized resources integration, right? So what are you going to do with this, right? People ask me, and I know we're out of time, but I'll finish with this. People look at this, and I think IBM in some ways has actually done not as good a job as we could have done in articulating the intent of this or the value proposition of this. Because, let me give you an example, and I'm somewhat flippant about this, probably get me in trouble at some point. But people ask me, like you kind of started to ask, well, I've got Linux over here and I've got Linux over there. Where should I run my Linux?
Yeah. My question was.
And my answer to you is, in this context, first of all, I'll point out to you that is, to whatever extent we have an answer to that or don't have an answer to that, it's exactly the same prior to zEnterprise as it is with it. Because the parameters of the question are what characteristics of the workload could benefit from a zLinux implementation, right? If the workload will benefit from a scalable vertical SMP infrastructure, if the workload can take advantage of the superior I/O bandwidth and sustained I/O rates of a System Z, right? If you have the need for large consolidations to take a lot of small images and put them on a single box to reduce complexity, right, and really drive consolidation, there's no better platform than that than Z and ZDM, right, et cetera. On the other hand, if you have workloads that actually work better in a scale-out infrastructure, they tend to be maybe stateless rather than stateful. Or the Linux provider that you're using, or the application, actually doesn't support a distribution on Z. Maybe that answer is predetermined, right? You have an application you're interested in, they don't support a distribution on Z, right? Because the business model maybe doesn't close for them. The volumes aren't there, maybe, right? So there's lots of parameters, but fundamentally they're the same today with this as they used to be. The second answer I give when people say, what workloads should I run on this? And it sounds facetious when I say it, but I say it, which is all of them. What is it about this thing? What is it that you need that this thing doesn't have? Right? Some people will claim, well, I've got workloads that don't fit on blades. I agree with that. So I modified my answer to all workloads that'll fit. Right? So it really doesn't matter to me, right, from a zEnterprise perspective, what the workload is. Right? It is a general purpose system that has compute capabilities, transaction capabilities, I/O capabilities, network capabilities, special purpose acceleration, right? And so, you know, we're open for business. Let's put our workloads on this thing, right? That's the way I see it.
Jeff, just a comment from experience on Wall Street. What Linux has given people the ability to do that no other operating system has been able to do is allow you to place the applications where you would like them, or perhaps you don't know where to start them, Professor Idle, but you have the ability to say, okay, let's say if I start here,
then move
things
it
change on it, it becomes more I/O intensive or something. Now I can move it over to here because Linux is Linux is Linux.
Yeah, the same argument applied for Java, right? And the Java-based runtimes, right? The issue of portability, to pick up stuff and move it around, is a very important point there, right? Where it ends up and how it's optimized and what you're willing to pay for it. I will admit, IBM needs to do a better job at providing the methodologies, right, to allow people to decide that, right? And the side effect of zEnterprise has been to put more focus on that question. But zEnterprise fundamentally doesn't inform the answer to that question, but it has given us the opportunity to focus on it. So we actually do have work going on to produce methodologies for helping customers understand the key characteristics of the workload and then to kind of right host them, right? And we use this as kind of a context for saying you have the freedom to do the right thing. Is that good enough?
Great.
Okay. Thank you very much.